good morning students. Today we can continue our topic of physics, that is the gravitation. So yesterday we have learned about the variation of acceleration due to gravity, due to, that means your or at the depth and as well as at particular height above the surface of earth. So the two expressions which we have calculated, the first expression above the surface of earth, acceleration due to gravity, will be goes on decreasing, and the expression that we have calculated, that is the acceleration due to gravity at the, that means at that particular point above the surface of earth, that gh that we have calculated, and that is equal to g 1 minus 2h by r. Okay, so that was the first expression, where this is the acceleration due to gravity at particular height, g is the acceleration due to gravity on the surface of earth, and h is the height above the surface of earth, and r is the, that means your radius of the earth. And here this expression is used for only when h is very smaller as compared to radius of the earth, comparable to it is not comparable to radius of the earth. And at the depth you have calculated acceleration due to gravity is equal to g is equal to 1 minus d by r, where d is the depth, r is the radius, g is the acceleration due to gravity on the surface of earth, and gh is the acceleration due to gravity at particular height. So in both the situations, that your acceleration due to gravity will be goes on decreasing. That things we have learned. Okay, so these are the yesterday's point that we have calculated, so that we have already finished this also, this also. Now today we want to learn the acceleration due to gravity on the surface of earth due to its shape. Okay, so now if I want to find out acceleration due to gravity due to its shape, so then sir, what will be the expression? Now you see here, earth is not a perfect spherical in shape, so it is elliptical in shape. Okay, if earth have this type of shape, then according to that shape, how the acceleration due to gravity is going to get changed. Okay, so you see here, acceleration due to gravity is changes due to its shape. So now here if you can say, this is the equatorial radius RE, and this is the polar radius, okay, RP. Okay, so you know RE is greater than, that is the RP. Okay, always RE is greater than RP. So how many times, that means how much that RE is greater than RP? RE is 21 kilometer greater than that of the RP. Means polar radius is smaller as compared to equatorial radius. Okay, so that is the your shape, due to the shape. This is the equatorial plane, means the earth is bulge, that means here at the equatorial plane, and at the near to the pole, radius will becomes the smaller one. So that is the condition, means we can say that here in this condition, as equatorial radius is 21 kilometer times more as compared to your polar radius. Okay, so that is the relation, means RE is greater than RP. Okay, but now you know, according to that radius, there is a relation is there. Acceleration due to gravity is going to get changed on the surface of earth also, as g is inversely proportional to r square. So therefore, as the radius of equatorial radius in the plane will be more, so therefore g will be less. Means acceleration due to gravity on equator will be less than acceleration due to gravity on the pole. Okay, so that will be the your relation. Okay, म्हणजे मुलांनो, या पोलार रेडियस ही नेहमी या इक्वेटोरियल रेडियस पेक्षा कशी असेल, जास्त असेल, म्हणजे ग्रॅव्हिटी इथं कशी असेल, जास्त असेल याच्यापेक्षा. आणि हिअर आपण प्रूव्ह करणार आहोत की हे नियर अबाउट द अर्थ सरफेस वरती जी आहे त्याच्या अगदी इक्वल टू ही ग्रॅव्हिटी ह्या पॉइंटला येते मुलांनो. इथे थोडीशी ती कमी झालेली असते, 0.00336 मीटर पर सेकंड्सने ती थोडीशी कमी झालेली आहे, म्हणजे तुमची 9.73 मीटर पर सेकंड स्क्वेअर, आणि इथं 9.8 9.8123. तर अशी ही ग्रॅव्हिटी या पॉइंटला तुमची येते मुलांनो. हे आपल्याला प्रूव्ह पण करायचं आहे. ओके, सो दॅट वी आर ड्यू टू द शेप हाऊ दॅट acceleration ड्यू टू ग्रॅव्हिटी चेंजेस. मग मुलांनो याच्यावर प्रश्न पण येतो की व्हेन यू आर मुव्हिंग फ्रॉम equatorial radius, equator to pole, the acceleration due to gravity will be goes on increasing. Okay, and when you are moving from pole to radius, acceleration due to gravity will be goes on decreasing. Okay, as the radius, polar radius is more than that of the your equatorial radius. So that is the relation, that is the variation of acceleration due to gravity on the surface of Earth due to its shape. Now once you got that this how that acceleration due to gravity, how it will be changes from place to place. Okay, because actually here this relation we are able to write down, because g is equal to, we have calculated gm by r square. So therefore g and m, they are the constant terms, so therefore g is inversely proportional to r square. So that things which we have learned. Once you got that things, then we want to learn the expression for gravitational or acceleration due to gravity on the surface at the latitude theta. But first of all, sir, what is latitude? So before proceeding to the latitude, I will define some terms, that is what is polar axis, what is equatorial plane, what is the latitude. Then you will come to know how that expression will be. So first of all, what is exactly polar axis? You know, polar axis means this is the polar axis actually. Okay, so if you can consider, that means your earth, okay, it will elliptical form. So now, so around which the earth is going to rotate with certain angular velocity, constant angular velocity. So that axis is the actually polar axis, because the earth rotates about its own axis. So which is that axis? That is the polar axis. So I will define that polar axis. The axis passing through north and south pole of a earth. Okay, axis which is passing through north and south pole of the axis. Okay, south pole of the earth, around which earth revolves. The earth, which can be, we can also say that axis passing, what is polar axis? The axis which is passing through north and south, and moreover north and south pole of the earth, around which earth revolves. So that is called as the polar axis. Okay, then now if this is the polar axis, means which is passing through north and south, and about which the earth is going to get rotates or revolves or around its own axis, so that is the polar axis. If this is the polar axis, then what is equatorial plane? Equatorial plane. Okay, आता हे मुलांनो, हे इक्वेटोरियल प्लेन काय प्रकार आहे? What do you mean by equatorial plane? Equatorial plane means the plane which is passing through the center, the plane which is passing through center of the earth and which is perpendicular to the polar axis. So that is called as the equatorial plane. What do you mean by equatorial plane? The plane which is passing through the center of the earth and which is perpendicular to this polar axis. So that is called as the equatorial plane. Once you got that equatorial plane, sir, then what is latitude? Okay, what is latitude? Okay, that latitude can be denoted by the theta also. Okay, so what is exactly this latitude? Okay, latitude. Okay, so what is that latitude? So particularly you see here, latitude means this is the angle. But which angle? That means suppose latitude, it will be defined as latitude at any point. Suppose this is the point P, which is lies on the earth's surface, and suppose I want to find out the latitude at this point P. So this is nothing but line joining the center of the earth to that particular point makes an angle with the equatorial plane. So then that is called as the latitude at that particular point. Okay, so at this particular point P, latitude will be theta. Means what is the theta here? That means this is the angle made by the equatorial plane with the point which connects to that center of the earth. So angle between the line joining the point and the center of earth with the equatorial plane, so that is called as the latitude of that particular earth surface. Okay, so again I will define what is latitude. Latitude at a place is defined as, it is the angle which the line joining the place A, suppose this or place P, line joining the place P to the center of earth, makes with the equatorial plane. Means this angle makes with the equatorial plane. So now here in that case, if I will say OP and suppose this is the A. So angle latitude will be AOP. So that is equal to theta. So that is called as the latitude angle AOP. So can you tell me what will be the latitude then at the equatorial point here? यहाँ पे कितना theta रहेगा? Theta will be 0. Theta is equal to 0 at equator. Equator पे theta कितना रहेगा बच्चे लोग? 0. And what will be the theta on the poles? Theta will be 90 degree. Okay, so that theta equatorial plane to the line joining to the point at place to the center. So this angle will be 90 degree. Okay, at poles. Okay, so this theta will be 90 degree, 0 degree, or only 40 degree, 60 degree. So these are the latitudes. Once you got the idea about, sir, what is exactly that latitude, then we are coming to the point that expression. Okay, which expression we are talking about? Expression for gravitational acceleration on the earth's surface at a latitude theta. Okay, so that expression we want to find out, and hence we can obtain the expression for acceleration due to gravity at equator as well as the pole. So we can find out that variation of acceleration due to gravity. I will rub this point now. So we are coming to that point. So this is the how variation of g is there on the equatorial plane or equator as well as on the poles or at any latitude. How we can calculate that acceleration due to gravity. So therefore our expression for acceleration due to gravity at the surface of latitude theta. Variation of acceleration due to gravity at the surface variation of acceleration due to gravity at the surface of at the surface at a latitude theta at the surface at latitude theta. ओके तर मुलांनो आता आपल्याला हे एक्सप्रेशन कॅल्क्युलेट करायचं लॅटिट्यूड थीटावर ॲक्सलरेशन ड्यू टू ग्रॅव्हिटीचं व्हेरिएशन कसं असणार आहे त्याच्यासाठी मी एक डायग्राम तयार करतो आधी ओके यू शुड ड्रॉ दिस डायग्राम अँड देन वी कॅन प्रोसीड ओके सो this is the suppose earth surface okay this is the earth surface so you can draw it properly it is not exactly spherical but we can draw this is elliptical in shape okay so this is the acceleration due to gravity and that is the earth and this is the radius of the earth okay this is the radius of the earth we can also say that this is the polar axis and this is the equatorial plane this is the equatorial plane okay now we can consider a latitude at particular point this is the point object is kept here which makes the angle theta okay this is the radius r of the earth okay that is the mass m is lies here now this body is going to rotate about this axis we can consider like this okay when the earth starts rotating about its own axis with the constant angular velocity that is the omega okay so this is the r now okay this will be the again theta so now this angle is 90 degree okay so here at this point the centripetal force which is acts on the particular object that weight of the object is towards the center O so that will be the F acceleration due to gravity that is the M into G towards the center so that F centrifugal force which is divided into two components okay so this one component and this is the another component they are perpendicular to each other so now if this is theta this is also theta so therefore this is F1 F cos theta and this is F sin theta okay I'll write down all these things how these things I'm going to explain. Okay, so now my point is how the acceleration due to gravity changes due to variation of latitude. Latitude means how that angle theta is going to get changed. You can calculate this point on the Earth's surface. What is latitude? The on where the object has been kept at this particular point. Okay, two line joining that point to the center of Earth makes some angle with the equatorial plane. So that is called as the latitude. So if the latitude is going to get changed, theta is going to get changed, how the acceleration due to gravity is going to get changed. So that things we want to learn. Okay. So now once you got that point, sir, how that things are going to get changed. So now first of all we'll start from that here at point. Okay, so yes, first of all, so this one point we have been considered. O will be the center, E will be that particular point, A will be the diameter, AB is the diameter, here this is the point E. Now you can consider, suppose at this latitude, okay, which latitude we want to calculate, latitude will be theta will be, कौन सा theta है बच्चों लिया मैंने, AOE, this is the latitude, AOE, so that is the theta. So at this particular point I want to find out the variation of acceleration due to gravity. Okay, so now once you got that AOE is equal to theta, this is the latitude, and Earth is supposed to be, that is going to get vary with the we can say with the constant angular velocity omega. So omega is equal to its angular velocity, and with that velocity, suppose Earth is going to rotate about its own axis, so that angular velocity is remaining constant. Okay, so now बच्चे लोग यहाँ पे the force which is exerted on this particle, that will be that here outward direction will be, which type of that force will be, that force will be centripetal force, or that is centrifugal force, which is acting, that means on the, that means outward direction. And so therefore when the particle is at a point m is the particle, m is the mass of the particle or mass of a body kept at a point E, kept at point E. So therefore that your latitude becomes AOE, that is the theta. Okay, and now the weight, weight of the force, weight, that is equal to mg acting towards the center, towards the center of the earth. त्यामुळे त्याच्यावर तो weight ह्या डायरेक्शन ने ऍक्ट होतो आहे. ओके, पण चलो, the centrifugal force which is acting on that particular point F is equal to mr omega square or mv square by r, where m is the mass of the particle, r is when the earth starts rotating about its own axis, then this particle is also revolving around that axis, will be here with this center O. Okay, या center मधून O dash म्हणून आपण वाटल्यास, कारण हे O is the center for that circle, earth we have considered, so therefore O dash is the center and the earth starts rotating about this radius r. So therefore, if r is the radius, m is the mass, and omega square is the constant angular velocity. So therefore, that will be the centrifugal force which is acting on the body. So this is the first expression. F is equal to mr omega square. But sir, now what is that r? That radius means if I want to find out that radius, so how I can calculate? You see here, if I will take, if this is the theta, so what will be the in triangle O dash E, O dash E, this right angle triangle. Can you tell me what is the cos of theta? Cos of theta. Cos of theta is equal to adjacent side upon hypotenuse. So adjacent side is r upon r. So therefore r is equal to r cos of theta. If I substitute this value here, so that centripetal force F will become, that F is equal to m r cos theta into omega square. So that will be the your force. Okay. So now if I got at this particular point, centrifugal force which is acting outward direction. So this is supposed to be second equation. But now if I want to calculate the other force which is acting on that particle at point O, that is the force due to gravity, that is the mg, which is acting towards the center. So therefore resultant force F dash, as F is equal to at the same point, F dash we can say that is the mg, or F due to gravity will be mg. So therefore net force F dash, okay, this one force, okay, but before that what I will do, that centrifugal force I will divide into two components, okay. F can be resolved into two components. First component is F1 that is equal to F cos theta, and F2 is equal to F sin theta. These are the two rectangular components, okay. So now if I want to find out F1, but F1 is equal to, I will write down here, F1 is equal to F cos theta, and so what is F? From equation 2, I will write down m r cos theta into omega square. M r cos theta into omega square into cos theta means I will say cos square theta, that is the F1, which is acting upward direction, okay. So this is third equation. But now gravity, that due to the gravity the force is acting towards the center, they are equal in magnitude, means they are opposite in direction. So therefore F dash is equal to, at this particular point E, F dash is equal to Fg, this force Fg will be greater than this force, so that is the F1, Fg minus F1. What is Fg? F dash is equal to mg minus F1. What is F1? M into R cos square theta into omega square, minus mg minus mr cos square theta into omega square. Now the resultant force acting at this particular point will be, that is mg dash is equal to mg minus mr cos square theta into omega square. M I will take out and I will remove that m. So therefore g dash is equal to m I will cancel, g minus r omega square cos square theta. I got the acceleration due to gravity at this particular point. So that answer will be g dash is equal to g minus r omega square cos square theta. Okay, so what this expression will gives to you, what this expression is telling. This expression tells me us like this: as the theta goes on increasing, theta increases, then cos theta will be goes on decreasing. So therefore, if this cos square theta will be goes on decreasing, the acceleration due to gravity g dash will be goes on increasing. कारण मुलांनो हा फॅक्टर जो आहे हा जेवढा कमी कमी होत जाईल तेवढा हा तुमचा, म्हणजे याच्यातून हा फॅक्टर कमी झाला, हा 9.8 आहे. याच्यातून आपण समजा 10 होता, 10 मधून 6 गेले, 4 राहिले, 10 मधून मी हा फॅक्टर वाढवला, 7 गेले, 10 मधून 7 गेले, 3 राहिले. म्हणजे माझं काय होणार, हा जर फॅक्टर मी कॉस स्क्वेअर थीटाचा वाढवला, म्हणजे थीटाचा वाढवला, तर कॉस स्क्वेअर थीटा कमी होईल. हा कमी झाला म्हणजे पहिल्यांदा 10 वजा 6 4 होते, आता 10 वजा आता कमी केले 5 केले, तर आता हा फॅक्टर 5 राहील, परत 4 केले 6 राहील. म्हणजे मुलांनो असं जसं जसं तुमचा थीटा वाढेल तसा कॉस थीटा कमी होईल, म्हणून जी डॅश तुमचा काय होत जाईल, वाढत जाईल. हे पहिलं एक्सप्रेशन. दुसरं, ओमेगाची किंमत जशी जशी तुमची वाढेल, as the omega goes on increasing, okay, agar if this omega, that means acceleration due to gravity is going to get changed due to omega, if somebody will say like this, then what will happen, omega increases, so therefore r omega square cos square theta will be increases, so therefore g dash will be goes on decreasing. म्हणजे जर का ओमेगा वाढायला लागला मुलांनो, तर जी डॅश तुमचा काय व्हायला पाहिजे, कमी व्हायला पाहिजे. ओके, सो दॅट विल बी द रिलेशन हाऊ द व्हेरिएशन ऑफ जी डॅश विल बी देअर ॲट अ पर्टिक्युलर लॅटिट्यूड. म्हणजे तुम्ही ते लॅटिट्यूड बदला, तुमचे ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी ह्या इक्वेशननुसार बदलत जाईल मुळात. मग मला ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी, आता हे जे एक्सप्रेशन तुमचं याचं असेल तर व्हॉट विल बी द ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी ॲट द पोल्स अँड ॲट द इक्वेटर. आय वॉन्ट टू फाइंड आउट दॅट एक्सप्रेशन ऑल्सो. So now how I can find out that expression? I will rub this now here in that case. So you see here, I have the relation with me of acceleration due to gravity, but I know g dash is equal to g minus r omega square cos square theta. Okay, so that will be the your expression. Now if I want to find out g dash or acceleration due to gravity, first at equator, okay, at equatorial plane or at equator. So now at equator theta is equal to 0, okay, 0 degree. So therefore g dash is equal to g minus r omega square cos square 0. What is the cos square 0? Cos of 0 is 1. So therefore g minus r omega square. So that will be the g dash, or we can say g at equatorial plane, or in equatorial plane g is equal to g minus r omega square. मग मुलांनो आता या केस मध्ये तुमचा हा जर थिटा 0 ठेवला तर जी किती येतो रे, जी मायनस आर ओमेगा स्क्वेअर इतका येतो. म्हणजे तो 9.8 पेक्षा कमीच भरेल मुलांना इक्वेटोरियल रेडियसवर. आता ते तुम्ही काढू पण शकता. आरची किंमत रेडियस ऑफ दी अर्थ टाकला, तुम्हाला तो माहिती होता मुलांना 6400 किलोमीटर, ओमेगा टाकून दिला तुम्ही, ओके, 2π/t. टाइम पिरियड ऑफ अर्थ रोटेशन इज 24 आवर्स, मीन्स 24 इंटू 60 इंटू 60. आणि तो जो तुम्ही एवढा सर्व कॅल्क्युलेशन्स केला 7 पॉईंट समथिंग इंटू 10⁻², तो फॅक्टर येईल आणि याला कॅल्क्युलेट केलं तर हे उत्तर तुमचं नियर अबाउट इक्वेटरवरती 9.73 मीटर पर सेकंड स्क्वेअर यायला पाहिजे मुलांना. दुसरा पॉइंट येतोय ॲट पोल्स. ॲट पोल्स इफ आय वॉन्ट टू फाइंड आउट ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी ॲट पोल्स. मग पोल्सवरती थिटा मी किती म्हटला, 90 डिग्री म्हटला मुला, 90 डिग्री. मग माझं इक्वेशन बघा, जी डॅश इज इक्वल टू जी मायनस आर ओमेगा स्क्वेअर कॉस स्क्वेअर 90. मुलांनो तुम्हाला कॉस ऑफ 90 माहिती आहे. व्हॉट इज द कॉस ऑफ 90? दॅट इज द 0. So if cos of 90 is equal to 0, then this expression will becomes like this, okay, as cos of 90 is equal to 0, so g dash is equal to g minus 0 or g dash is equal to g. माझ्या g dash लाच मी काय म्हणतो मुलांनो, पोल्स. म्हणजे पोल्स वरती माझं इक्वेशन किती आलं, g इतकं आलं. मग मुलांनो म्हणजे इथे जर 9.73 असेल तर इथे 9.8 मीटर पर सेकंड येतं मुलांना. ओके, म्हणजे दोघांमधला सर डिफरन्स किती असणार आहे, मग आपण त्याला काढू शकतो. जीपी मायनस जीई इज इक्वल टू, जीपी मायनस जी जर मला पाहिजेच असेल मुलांनो, तर जीपी मायनस जीई इज इक्वल टू, जीपीची किंमत जी मायनस आर ओमेगा स्क्वेअर, मग जी मायनस जी प्लस आर ओमेगा स्क्वेअर. म्हणजे किती उत्तर आलं रे, आर ओमेगा स्क्वेअर जीपी मायनस जीई. ओके, मग तुम्ही जर आर आणि ओमेगाच्या व्हॅल्यू जर ठेवून दिल्यात मुलांनो, तर तुम्हाला तो आर ओमेगा स्क्वेअर नियर अबाउट 0.03386 मीटर पर सेकंड स्क्वेअर येतो. म्हणजे नियर अबाउट 0.03368 मीटर पर सेकंड स्क्वेअर. हा एवढा ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी मधला मुलांनो तुम्हाला चेंज दिसणार आहे. ओके, 9.3 9.73 याच्यामधला हा नियर अबाउट आपण काय घेतला मुलांनो, इफेक्ट काढला की हाऊ द ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी इज गोइंग टू गेट चेंज. ओके, मग मुलांनो हे सर्व आपण वेगळे व्हेरिएशन्स त्याचे आपण काय केले मुलांनो, नोट करून टाकले. ओके, 0.03386. Okay, so that will be the change in acceleration due to gravity on the poles and the equator. So that we have calculated. मग मुलांनो आपल्याला आता काही पॉईंट याचे डिस्कस करायचे की सर डिस्कस द डिफरंट पॉईंट्स व्हेरिएशन ऑफ जी विच वी हॅव लर्न अप टू दिस पॉईंट अँड डिफरंट पॉईंट्स डिस्कस विथ द एल्टिट्यूड डेप्थ अँड लॅटिट्यूड. ओके, मग मुलांनो आता हे सर्व आपल्याकडे आल्यानंतर आता आपण त्यांचे वेगवेगळ्या पॉईंटला ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटीचे काय काय इक्वेशन होते एका ॲट अ ग्लान्समध्ये त्याला आपण नोट करू मुलांनो आणि आपण आता पुढे सरकू. ओके, मग आता एक मिनिट मी तुम्हाला याचा की सर आपण काय काय अभ्यास केला बघा. ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी मी कुठे बघितली होती मुलांना, पहिल्यांदा काढली ॲट हाईट एच, ॲट हाईट एच वरती म्हणजे जी एच. त्याचं एक्सप्रेशन मी तुम्हाला सांगितलं होतं मुलांना, जी इन ब्रॅकेट 1 मायनस 2h बाय आर. ओके, पहिले एक्सप्रेशन. त्याच्यानंतर मुलांनो दुसरं एक्सप्रेशन ॲट अ डेप्थ, डेप्थ वरती डेप्थ, आणि त्याला आपण डी म्हटलं. मग जी डी इज इक्वल टू जी इन ब्रॅकेट 1 मायनस डी बाय आर. ओके, या दोघं केसमध्ये ॲज एच इन्क्रीजेस तुमचा जी एच विल बी गोज ऑन डिक्रीजिंग. डेप्थ increases, GH will be goes on decreasing in both the cases. Okay, आणि मुलांनो at what point GH is equal to GD, so D is equal to 2H or H is equal to D by 2. So that is the point where the both the gravities will be same. Third point which we have calculated for the latitude, at a latitude, at a glance we have learned, so acceleration due to gravity g will be at a latitude L is equal to किंवा at a latitude आपण त्याला काय म्हणू शकतो मुलांनो, g theta, variation of g with the latitude means that is the theta. ओके, मग त्याला आपण g dash नाव दिलं, g minus r ओमेगा स्क्वेअर कॉस स्क्वेअर थीटा. हे तुमचं एक्सप्रेशन आलं म्हणा. ओके, आणि ह्या एक्सप्रेशन वरनं आपण पोल्स आणि कुठे काढलं मुलांनो, त्याच्या इक्वेटोरियल रेडियस वरती नोट केलं. मग आपण ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी इज मॅक्झिमम ॲट द पोल्स अँड मिनिमम ॲट द इक्वेटर. ओके, it will increases from acceleration due to gravity increases from equator to pole, and acceleration due to gravity decreases from pole to equator, and that difference will be that also you have calculated. Means at poles g dash is equal to g because cos of theta is equal to 90. theta किती होता रे, 90 होता, म्हणून cos of 90 0 झाला. and at equator g dash is equal to g minus r omega square. ओके, तर मुलांनो हे सर्व एक्सप्रेशन्स तुम्ही कॅल्क्युलेट केलं. सो दॅट इज द व्हेरिएशन ऑफ g that we have calculated. Once you got that thing, so I will give one example to you, numerical to you on the variation of g. ओके, तर मग मुलांनो लॅटिट्यूडवर एखादा प्रश्न बघू आपण आणि मग आपण प्रोजेक्शन ऑफ सॅटेलाइट कडे जाऊया. Write down, if Earth were to stop rotation, about its own axis, what will be change in the value of g at a place of latitude 60 degree. Okay, म्हणजे मुलांनो त्याने आपल्याला थीटा किती दिलाय रे, 60 डिग्री देऊन ठेवलाय. आता हे पुसून टाकतो मुलांना. ओके, आता त्यांनी काय सांगितलं, चेंज करायला लावलाय त्यांनी. कुठून कुठपर्यंत, इफ अर्थ वेर टू स्टॉप रोटेशन अबाउट इट्स ओन ॲक्सिस, म्हणजे तो जर तुमचा ओमेगा 0 करून टाकला मुलांना, स्टॉप रोटेटिंग अबाउट इट्स ओन ॲक्सिस, what will be the change in the value of g at a place of latitude 60? Assume earth is a sphere of a radius 6400 किलोमीटर. आता मुलांनो दिलेलं काय काय बघा, थीटा दिलाय तुम्हाला 60 डिग्री, हा 60 डिग्री म्हणजे इथला अँगल तुम्हाला देऊन ठेवलाय. रेडियस ऑफ द अर्थ पण दिलेला आहे 6400 किलोमीटर. ओके, आणि तुम्हाला विचारलं काय गेलं मुलांनो, जी डॅश Okay, g dash minus g, change in value of acceleration due to gravity at latitude theta. Okay, मग आता मुलांनो पहिली गोष्ट, तो तुमचा ॲक्सलरेशन ड्यू टू ग्रॅव्हिटी नियर ॲट द पोल्स आपला किती होता रे? तो तुमचा थीटा 90 होता, म्हणजे तो जी डॅश तुमचा हे येईल. ओके, तो काढू आपण. पण त्याच्या आधी मला आता ओमेगा लागेल मुलांनो. ओमेगा मी कसा काढणार रे? ओमेगा यू नो, ओमेगा इज इक्वल टू 2 पाय बाय टी. मग 2 इंटू 3.14 and t 24 hours time period. So 60 minutes 60 seconds. Okay, so first of all you can calculate that omega, and that omega is come out to be 7.2 into 10 raised to minus 5. 7.2 into 10 raised to minus 5 radian per second. Okay, मुलांनो मला ओमेगा तर अर्थचा हा कॉन्स्टंट ओमेगा मिळून गेला. आता आपण ॲट लॅटिट्यूड थीटा ड्यू टू रोटेशन ऑफ द अर्थ जी डॅश आपण काढूया. ओके, वेन अर्थ स्टॉप्स रोटेटिंग, मग ओमेगा जर झिरो झाला तर ॲक्सलेरेशन ड्यू टू ग्रॅव्हिटी ॲट दॅट प्लेस विल बी. पहिले त्यांनी काय सांगितलं की अर्थ वेर स्टॉप्स रोटेटिंग, म्हणजे तुमचा ओमेगा तुम्ही झिरो करून टाकला. मग त्या पॉइंटला तुमचं मुलांनो हा जी डॅश किती येईल बघा बरं, जी मायनस आर ओमेगा स्क्वेअर कॉस स्क्वेअर थीटा. मग जी डॅश इज इक्वल टू जी येणार, कारण तुम्ही ओमेगा काय टाकला रे, झिरो, म्हणजे जी मायनस झिरो दॅट इज इक्वल टू जी. म्हणजे मुलांनो पहिली गोष्ट मला जे इक्वेशन मिळालं की ज्यावेळेस अर्थ स्टॉप्स रोटेटिंग म्हणजे जी डॅश इज इक्वल टू काय आला, जी आला. आणि दुसरं ॲट अ इक्वेटर, म्हणजे तुमचा लॅटिट्यूड किती डिग्रीला म्हणतो तो, 60 डिग्रीला. थीटा इज इक्वल टू 60 डिग्री म्हणजे लॅटिट्यूड 60, देन जी डॅश विल बिकम्स, म्हणजे आपण त्याला जी डॅश 1 असं म्हणू लॅटिट्यूड वरती. तो किती येईल रे, जी मायनस आर ओमेगा स्क्वेअर कॉस स्क्वेअर 60. मुलांनो कॉस स्क्वेअर 60 किती येणार तुमचा, कॉस ऑफ 60 विल बी हाफ, म्हणजे त्याचा 1/4 येणार. म्हणजे तुमचं हे उत्तर जे येतं जी आर ओमेगा स्क्वेअर कॉस ऑफ 60 विल बी 1/2 मीन्स 1/4. सो दॅट विल बी जी डॅश किंवा जी डॅश 1 आपण असं त्याला लिहू शकतो. ओके, मग मुलांनो आता हा तुमचा मी एक काम करू शकतो अजून, की जर तुम्हाला चेंज इन द व्हॅल्यू ऑफ ॲक्सलेरेशन ड्यू टू ग्रॅव्हिटी, म्हणजे ह्या इक्वेटरवरनं त्या जी वरची काढायची होती. आपण कसं करणार माहिती का, द चेंज कॅन बी डिनोटेड बाय जी डॅश 1 मायनस जी. ओके, जी डॅश. ओके, जी डॅश 1 मध्ये माझं इक्वेशन काय आहे रे, जी मायनस आर ओमेगा स्क्वेअर कॉस स्क्वेअर थीटा. ओके, आणि मला तो चेंज कसा काढावा लागेल मुलांनो, जी मायनस जी डॅश करावा लागेल. जी डॅश मायनस जी. ओके, म्हणजे मला हा जो फॅक्टर आहे मुलांनो, हा जी मोठा असेल ना पोरांनो, म्हणजे मग मी काय करेल त्याला जी मायनस ऑफ धिस फॅक्टर, मग दॅट विल बी जी मायनस, म्हणजे तुम्हाला जी मायनस हा जो तुम्ही पहिला काढला ना जी डॅश मायनस जी डॅश ऑफ 1, मग हा जी मायनस जी प्लस आर ओमेगा स्क्वेअर कॉस स्क्वेअर थीटा हा कट झाला मुलांनो. मग आर इंटू ओमेगा स्क्वेअर इंटू कॉस स्क्वेअर 60 हा तुमचा चेंज असेल मुलांनो. मग याचं उत्तर किती येतं बघा, रेडियस माहिती आहे, ओमेगा माहिती आहे, कॉस स्क्वेअर 60 तर माहिती आहे तुम्हाला 1/4 येतो. मग आता रेडियस ऑफ द अर्थ किती टाकणार रे, 6.4 इंटू 10⁻6 मीटर, किलोमीटरचं मीटरमध्ये केलं. ओमेगा तुम्ही वरती कॅल्क्युलेट करून ठेवलाय 7.2 इंटू 10⁻5 अँड दॅट इज 1/4. आणि मग मुलांनो तुमचा हा जर चेंज जर तुम्ही काढला तर तो नियर अबाउट 8.45 इंटू 10⁻³ येतो. 8.45 इंटू 10⁻³ ओके, मीटर पर सेकंड स्क्वेअर. सो दॅट विल बी जी डॅश मायनस जी डॅश 1. ओके, म्हणजे अर्थ वेअर सडनली स्टॉप्स रोटेटिंग अँड ॲट अ लॅटिट्यूड ऑफ 60 डिग्री. So how variation of g will be there. Okay, so that things we have calculated. Once you got that things bachalo, then we have to proceed for the next point, that is the projection of satellite. आता प्रोजेक्शन ऑफ सॅटेलाइट काय प्रकार आहे सर, व्हॉट डू मीन बाय प्रोजेक्शन ऑफ सॅटेलाइट. मग त्याच्यासाठी आपल्याला सॅटेलाइट काय आहे हे आपल्याला आधी बघावं लागेल. ओके, हे सर्व आपण काय अभ्यास करत होतो मुलांनो, व्हेरिएशन ऑफ ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी. तर आता आपल्याला बघायचं आहे सर व्हॉट इज एक्झॅक्टली युअर सॅटेलाइट, what are the types of satellite. Okay, so we can proceed for the next point. What is projection of satellite? Projection of satellite. Okay, so that point we want to learn. So for that, first of all sir, what is satellite? Okay, what is satellite? Satellite means any heavy body which is revolving around the earth in a fixed orbit, so that is called as the satellite. Okay, heavenly body which or any heavy body which can be rotated around the, or heavy body which can revolve around the planet in a stable orbit, it is called as satellite. So now means for example, if I will take, suppose sir this is the earth, and around which suppose any heavenly body is rotating for a particular purpose, so that is called as the satellite. Now this satellite have the two types. One is natural satellite and second is natural and artificial satellite. Okay, artificial satellite. So what is the natural satellite? That is the, that means your earth. Okay, so earth which that means revolves around the sun, means earth is the natural satellite of earth. Earth is natural satellite of sun. Natural satellite of sun. Or moon is the natural satellite. Moon is natural satellite of, moon is natural satellite of earth. Okay, so they are not kept for a particular purpose, but artificial satellite means a man-made satellite. That is the man-made, means for a particular purpose the man has set the satellite around the earth. Okay, so that is called as the artificial satellite. Man-made satellite which have been made to revolve around the earth is known as artificial satellite. So which are that? So for example, Aryabhatta. Okay, then now INSAT, Apple, Rohini. Okay, Rohini. So then Apple. Okay, okay, Aryabhatta. Again INSAT. Okay, INSAT. Okay. So Indian satellites. Okay, so these are the artificial satellite. So what are the uses of that satellite? For what purpose you are setting that satellite? Means there are some purpose are there. That is called as uses. For particularly you can use this satellite for communication point of view. Okay, so what is that? Communication. Okay. Second thing is military purpose. Okay, military purpose. Okay, you can set the satellite into that orbit. Or study of atmosphere, astronomical study. Okay, study of atmosphere. Study of atmosphere. Okay, astronomical study. Okay, so for that purpose we are using that satellite, so that is called as the, that means your different satellite for set for the particular purposes. Okay, so then now how the projection can be done, so that things we can see in the next lecture. Okay, today we'll stop.